Okay, so in this example, there's a linear association between the height and weight of a sample of 6 women. We are given a regression line equation. Weight equals negative 442.882 plus 9.029 times height. What does the regression line equation tell us? Interpret the slope and y-intercept. And so if we're thinking about our equations of lines, when we're dealing with algebra classes, we generally think about our equation of our line of y equals mx plus b. Right? The difference in what we see here is we don't see any x's, we don't see any y's. Instead, we've left our variables as words, and we've slightly rearranged the shape of our equation. So this weight, this number that's all by itself, well, that's our y variable. That's what's being predicted. Right? So we've got our y there. Right? What's doing the predicting is our x variable. So that is our height. The number connected to our height, right, the number connected to x is our slope. So that 9.029 is our slope. And this negative 442.882, that number that's all by itself, that's our b. That is our y-intercept. So we're going to use this equation to do some interpretations here. So what does the regression line tell us? Interpret the slope and the y-intercept. All right, so let's start with the slope. The slope tells us that the weight which is our y value, right, increases 9.029 pounds right, because that is our value of our slope for every 1 inch in height, which is our x. Right? Because if we go back up here, we were told that our slope tells us how much the y variable changes when the x value is increased by 1 unit. So we increased our x, our height, by 1 unit, and our weight increased by a positive, because it's a positive, that's why it increases, by 9.029 pounds. Right? The y-intercept tells us, right, so again, if we go up here, our y-intercept tells us the predicted value when x equals 0. So the y-intercept tells us a woman who is 0 inches tall tends to weigh negative 442.882 pounds. Nothing about this sentence makes sense, right? It's impossible for a woman to be 0 inches tall, and it's impossible to have a weight that is negative. So our y-intercept isn't necessarily always useful, so we're just going to put a little note here. It does not make sense in this scenario. So again, our slope tells us what happens when x increases by 1. So for every 1 inch in height, the weight increases by 9.029 pounds. Our y-intercept would tell us what happens if we have a height of 0, which is impossible. So really the only useful interpretation comes from that of our slope in this case.